So yeah, like Archana mentioned, I'll be talking about how you can use Azure ML to train models and to deploy your models as well. Um, some of the things that I'll be talking about is what is like the ML workflow in the industry right now. So how do you go from, like raw data to like pre-processing it and then, exploring it, training your model and then deploying it. And it's not as simple as that. And as we'll see, like there are a lot of steps that you have to follow when you want to deploy a model in an industry as compared to, when you just do a machine learning project. Um, and in regards to that, we'll actually see how you can use Azure ML to actually work with various parts of that deployment pipeline. So like how do you manage multiple training experiments? How do you test your models? How do you deploy them? And how do you do some other things like hyperparameter tuning and AutoML? And finally, I'll finish with some other cool Azure ML features. And yeah, that's it. So we'll be doing like, so I'll be, shifting from my slides to actually showing you all of the concepts that we'll be learning in Azure ML. And in case you have any questions, just feel free to put them in the Q&A or in the chat, and Archana will let me know. Okay, so what this talk is not about. So this is an introduction to Microsoft Azure and Azure ML. It's not an introduction to machine learning. So you're expected to like know what machine learning is. I'll also be not talking about like what the different kinds of ML models are, how you should pre-process your data. What are the good practices like for pre-processing data, feature engineering, stuff like that. That's because like I'm not trying to kind of like get state of the art in the examples that I'm trying to show you. I just want to show you how you can use Azure's different features to really streamline and make your ML pipeline really fast and development really fast. So yeah, so I hope you already know all of this. If not, I think like Bhuminu Code is also doing some other sessions on like an introduction to ML, and yeah, you can join that in as well. So with that being said, let's get started. So this is what like a typical ML pipeline will look like. You'll first get data, which is oftentimes actually one of the most toughest tasks, right? Like either the data is not like either you can't find data or the data you find is not good enough. Maybe it needs a lot of pre-processing and all of that. So yeah, you need to first get data. After that, you need to clean and manipulate your data so that you can send it to a machine learning model to train. Once you've cleaned your data, you start training models. You might train a few different architectures and see the kind of results you get, and then and basically you test you do this thing again and again where you train a model, you test it, you try to see if the performance is good or not, and then you iterate through that. So yeah, this is what a typical ML pipeline looks like. Um, but in reality, when you actually work in an industry, it's not that simple. You actually have to worry about a lot of things. Stuff like where do you store your data? What about versions of data? You also have to worry about, let's say, like retraining your model as your data changes. So that's called data drift, and you have to account for data drift as well when you're deploying a model. Um, you also need to have a good way to actually show all the model metrics to either other people on your team or to the business units in your company, so that they can verify. You need to show them the outputs as well. You need to think about how you deploy it and the deployment costs. You need to think about tracking what kind of input pre-processing pipeline was used to train a certain model. And yeah, so you have to worry about a lot of things in reality, right? And you probably also will not be working on just one project at the same time. You'll be working on like maybe two projects, and this whole stack, it kind of gets doubled at the time, right? So you have to keep tracking a lot of these stuff. And then if if you're someone who's also responsible for like your DevOps or your infrastructure, then you have to worry about some more stuff as well, like the environments. Some random data scientist might just give you a Jupyter notebook, and then it will be your job to um, recreate that, like turn that into a Python script, and then it won't run, and like maybe the order, the execution of the cells is different. So yeah, it's a mess, right? You have to think about saving the models. You have to think about tracking your experiments, labeling your data. If you're deploying it, you have to worry about when the system is down and then send alerts and all of that stuff. Um, so yeah, you have to worry about like a lot of things when you actually work in an industry and you have to deploy these models. Um, and I'm not saying like Azure can actually do all of these things, but they certainly make a lot of these things easier. Um, so what does Azure ML, what does it help with? It does, it definitely helps with simplifying your training, testing, and like training, testing, and then improving pipeline. It also has stuff like hyperparameter tuning. But in addition to that, it also manages and tracks your environments. So different experiments might be using different versions of, let's say, NumPy or Pandas, and it tracks all of those environments. It also helps you deploy your models really easily and from Jupyter notebooks as well. And we'll be seeing this later on. You can also, it also helps you save like pipelines, data storage, and even data versioning, and labeling. That's also something that Azure supports. And finally, model storage and versions as well. And it also shows you like the different metrics across the different training runs of your models. Um, so yeah, so these are some of like the advantages of using Azure ML. And these are some of the things that Azure, it just makes things, it just makes your life easier. Okay, so this is the website for Azure ML. If you create a new account, I think you get like some $200 of credit that you can use to try out all of these features. And there are also some features that are available for free. But yeah, if you want to follow along, or if you want to try these things out later, this is where you can go. Okay, so let's get started. Um, so everything in Azure ML, and Azure ML Studio is like there's a big bucket at the beginning that's called a workspace, where all your compute, all the data that you're using, models, deployments, everything is like present inside that one workspace. You can have multiple workspaces. So you might be working on different projects, and you might have one workspace for each project. Or maybe you have like you're working in a team, and then you have like 10 people in a team, and one person might get one workspace. But yeah, it's basically how you group your experiments, and everything else that's associated with your experiments, like your data and all. So let's see how we can actually create a workspace. um, so this is how we can go to Azure ML Studio. When you first start your studio, you probably will not be seeing all of this, but you can click New, and my bad. Uh, yeah, I think you have to go to Azure. Yeah, so once you're here, you can create a resource. Sorry. You can click machine learning. And then, so this is the workspace that I already have. And you can add another workspace. Yeah. Um, sorry. Yeah. So you can add another workspace. Yeah. So just put your subscription. So this might be like your, if you have credits, you can put this in here. And then, create a resource group. So I'll just use my existing resource group and then give your workspace a name. Select a region. Um, Usually I don't register any containers. And then, yeah, you can review and create. So I won't create one right now because it takes some time, but I already have one created over here. So once we are here, you'll notice a few things. So you'll notice on the left-hand panel, you have like notebooks. You also have some of the assets. So these are the different things that are available in Azure, like data sets, tracking experiments, tracking of pipelines, model endpoints, and so on. And you also have some compute. So let's look at the computes that we have. So there are four types of computes available in Azure ML. There's compute instances, compute clusters, inference clusters, and attached computes. Um, so a compute instance is like it's just a simple instance that is used only for development. So for instance, you might be running a Jupyter notebook, and it's just used for development. So your Jupyter notebook in the backend will be running on a simple compute instance that might have like 2 or 4 CPUs. Um, and the main purpose of the compute instance is to just write your code and then submit that code to run on a compute cluster. So compute cluster, on the other hand, it's used for training models, and it's also another virtual machine, but it's a more powerful virtual machine, and it might have 8 CPUs, or it might also have a GPU depending on how you configure your cluster. And also another awesome thing about compute clusters is that it can be scaled up and down based on the amount of compute that you need for training. And so, for instance, if you're training, like, let's say, an AutoML model, right? So it's probably going to run many experiments. So you might want to scale up your cluster so that each node has one experiment running on it. So Azure ML handles that for you. And yeah, its basic purpose is used for training models. Um, Now, the kind of machine that you use for writing code and training models is going to be different from the kind of machine that you use for running inference, or where you deploy your models, right? So that's why Azure ML has another kind of cluster called an inference cluster. And it's usually like a Kubernetes cluster, and it's used for deploying models so that people outside can consume it. And we'll also see uh, how we can request all three of these types of clusters and deploy models to them. Finally, we also have this thing called an attached compute. So this is where you can attach any extra compute that you might need for any of your projects. You can attach like your local computer, or you can attach like any other Azure virtual machine or container. Um, so yeah, let's look at how we can train a model in Azure. So the first step is to connect to a workspace. Now, remember, I'll just tell you the steps first, and then we'll actually see how to do it in Azure. Um, so why we need to connect to a workspace is because our workspace is where all of our data and our experiments and all our compute nodes and all that, right? So all our experiments, like let's say for a project, is we will tag it to one workspace so that we can track everything in that one workspace. So before you actually start working on Azure ML, you'll have to connect to the workspace that where you want your experiments to be tracked. Um, once we create a workspace, we have to also create an experiment. Um, so, every time we train a model, we have to create an experiment that we can track. So that experiment will have all the details like which model was trained, what's the accuracy of the model, what's the performance, and so on. Remember that we write our Jupyter notebooks in a compute instance, but we have to submit it to a compute cluster for training. So we also have to create a compute cluster where we submit our training job, and the job that we will submit, that's going to be a script, so we'll also have to write that script. And finally we'll also have to write some so the compute cluster doesn't know the kind of environment we need to run our script, so we also have to submit, like, along with our training job, we also have to specify like the packages that the training job needs, any other scripts, a source of data, and so on. So yeah, let's take a look at this. So when you're in Azure ML, click Notebooks. So I already have a few notebooks that's already running, so that I don't run it during the uh, talk. But what we'll do for now, just because we are just learning, is we'll go to samples. So in samples, Azure has a few sample notebooks that are present. Um, so click on tutorials, and we'll try to classify an MNIST data set, which is probably like the hello world of any machine learning problem, right? So what you can do is you can click this menu button and then click clone, and then you can clone it into your personal directory. So in my case, my directory is hello, and you can see I've already cloned it, so I'm not going to clone it right now. But yeah, once you've cloned it, it should be available over here. So yeah, let's look at the notebook. So this is the notebook, and this is how, like, I'll just be going through the notebook right now. So first we import like NumPy and Matplotlib, like standard stuff, and then we import Azure ML and Workspace from Azure ML. So remember, the first step is to actually connect to a workspace. So that's what we'll do first. So yeah, so we get the config of our workspace, and basically that's it. So right now we are running it in Azure, so the config is already present in it. But in case you're running this on your local computer, you will have to like save this config on your local computer when you run it. But yeah, so then you get a config object, sorry, a workspace object, and you can also print like some of the details of the workspace as well. So for instance, my workspace, the name is Women Code. It's in Southeast Asia, and the resource group that I'm using right now is also Women Code. Yeah. So once we connect to a workspace, we have to create an experiment. So this is what we're doing here. So to create an experiment, you have to specify an experiment name. And then we import experiment from Azure ML core. And then we just initialize an experiment object with our workspace object and an experiment name. So now that we've initialized our experiment, we can actually track it over here, and I'll show you that in some time. Okay, so now that we have created a workspace and an experiment, we have to either create or attach to a compute cluster where we can submit our training job. Um, so yeah, so this is how you can do it. So you can save, like your cluster name and all as environment variables, or you can just specify them normally. Although, like, when you actually deploy it later on this, you would probably want this to be environment variables. But yeah, so for my case, I'll just give it a name called CPU cluster, and I'll specify that, like, the minimum number of nodes is 0, and at max only spin up 4 nodes. Um, and the type of VM to use. So I'll be using a standard D2V2 VM. I think this has like I think 4 CPUs. I'm not sure, but yeah, this is kind of like the standard, and you can and you can look at the specifications in the documentation later on. But yeah, anyways, like the specification is really not that important. It's just the fact that you can really easily like spin up instances using just code. So yeah, so in case our compute is already running and present, we don't want to restart it. So just check if the compute is already available in compute in our compute targets in our workspace basically. If it is, then great. We'll just print that yeah, we found the compute. If not, then you can also actually create your compute right from your Jupyter notebook. And to do that, like this is some boilerplate code that you can use to do that. Um, yeah. So once we've created our compute, and yeah, creating your compute, it takes a while. So that's why I've kind of done this before. Um, we can do some we can like now focus on on the machine learning project itself. So we first fetch the data. In this case, this is like a sample project, so we are fetching our data from Azure's, like data, open data sets, which has a few data sets. It has some classifications, some regression data sets as well. And yeah, so remember I talked about data versioning. So this is how you can register your data set to your workspace. And what that will do is that will track your data throughout the experiments. And also it will track different versions of your data. So like in case you have some, like, let's say, data pre-processing steps or data augmentation steps, um, you can do your augmentation like beforehand and then register that augmented data as a new data or as a new version. And Azure will track that for you, and you can use that data later on, and we'll see how we can do that as well. Okay. So yeah, this is some boilerplate code to show some of the images. But what's important is training on a remote cluster. So how do we submit our job to a remote cluster? So remember, like, we have to create a training script. So that's what we do first. This is what the script looks like. It takes a few arguments, like the data folder and like a regularization number. And these are arguments that our training script will. So this is a training script. So we'll be passing it to our training script using a training job that we'll specify later on. Um, so yeah, so it loads the data, prints the shape, yeah, gets a hold of the current run. So you want to track experiments, right? So to track experiments, you need to know what the current experiment run is. So that's what this does. It trains like a simple logistic regression model. Remember, like, the exact model is not really important. We're not trying to beat the state of the art here. Um, and yeah, we fit the data, and then we log our regularization rate as well as our accuracy, and then we dump our model to this output folder. So it's a very simple training script, uh, but there are a few like key things that I want you to take a note of. So the first thing is like logging. So because we are logging these two things, we can track them later on as a part of our experiments. And we can and also remember, like, anything that is dumped to the outputs folder will be available in your compute in your Jupyter notebook later on. So you can use that later on to deploy your model or save your model. Okay, so now we have to configure our training job. So to configure our training job, we have to create an experiment. Sorry, we have to create an environment. So that's what I've created here. And you also have to specify the different pip packages, like the Python packages that you need. So for instance, for this, I need like pandas, I need Azure ML, and I also need Azure ML datasets. I need scikit-learn as well. And yeah, so now this environment is also registered, and I can track this environment as well. Um, so this is how you can register your environment and use it later on. Um, and yeah, and next we have to like submit a job to the cluster. So to submit the job, we have to create a script run config, and where we specify the script that we want to run, the arguments that I've specified here. So the regularization rate as well as the data folder. So these arguments will be sent to a script when it runs on the compute cluster, our environment. Um, and yeah, the compute target where we want to run our training job. So once you've specified all of these things, we can submit the job, and you can and it will show you these links where you can actually start to track your model. But you can also track your run inside the Jupyter notebook as well. And this is what that looks like. So Jupyter. So what happens in the backend is that Azure ML will start to create a Docker container that has your training script and your data and all of that, and it'll run your code inside that container, and then with the environment that you specified, and then send the results. Um, yeah, so this is this is showing the logs, where you can see that it let's see, where did it, yeah, so you can see the logs, like who submitted it, and ideally you should also find your regularization rate and all of that somewhere here as well. I'm not gonna look at that right now. But for instance, you can see like some other stuff like your the number of CPU cores and memory and all of that. Uh, Okay, so yeah, so once our run has finished, we can get the metrics. So we have, we've got an accuracy of 91.93 with a regularization rate of 0.5. And yeah, we can now register our model. So registering our model helps us track our models as well. And this is how you register it. So you can give your model a name and then the path that contains your model file. And yeah, that's it. So let's take a look at all of these things that we created. Um, so if I go over to the experiments tab, I can see that I have, like my scikit-learn tutorial experiment over here that I just ran. Um, so if I click this, you can see that. So I just ran it like right before starting this talk, and it's the second run that I ran. So yeah, it tracks the different runs as well. So I ran this one last night as well. If I click here, then I can get the logs. Um, I can also get the metrics that was logged. So like the accuracy and the regularization rate. Um, let's see. Yeah, we didn't create any images, and we didn't create any child runs either. We'll take a look at these later on. What child run is and what are images. But yeah, so this is how you can track your experiments, models as well. So this is my scikit-learn MNIST model. You can see that there are oh, sorry. Yeah, you can see that there are a few versions of the model. You can also see the experiment that was used to create the model as well as the run ID. So everything is kind of like linked, right? Um, and yeah, so you should also be able to see our train data that we use to train our model. Yeah, over here. Okay, so I know I covered a lot of stuff, but are there any questions till now?
Yeah, actually, we do have a few questions. Let me
Mhm.
take it up. So,
Yeah.
first is what kind of errors do you usually get on when running it for the first time?
Yeah, that's a good question. So ideally, um, you know, um, I would not run it directly on Azure ML. I would probably run my training job once locally to see that everything is working, at least for, like maybe one batch, just to see like if my data pre-processing pipeline and my, job save and my model saving and all is fine. Um, so ideally that step won't fail. But what usually fails is, uh, you maybe forget to change some of the configs, or some of the environment variables, and maybe you forget to um, specify the correct Python packages that you need. And these errors are usually like very costly because on Azure it takes like, I don't know, 2-3 minutes to spin up a new cluster for training. So every time something fails, you'll have to like wait for like 2 minutes for the cluster to start up, and then another 3 minutes for it to spin up the Docker container, and then run your code and then get the logs. So yeah, it's like 5 to 7 minutes that you have to wait just to see an error, like a really dumb error message. And that's actually what was happening to me last night as well, and it's really frustrating. But yeah, usually it's errors like that where you either forget to specify like your Python package, or like you um, you set up your environment incorrectly. Yeah. Any other questions, Arsan?
Yeah, so we have what twists do you like do we need to apply to your pipeline code besides connect to a workspace and to a cluster?
Sorry, what? Sorry,
I think they asked like what twist do you need
what
to
twist?
apply to the pipeline code as such that you can connect to a workspace and connect to a cluster.
There's no, so you don't have to change your training script, because like I showed you here in my notebook, my training script is like, it's a normal training script, right? There's nothing really, like I can take this and I can run it locally as well. It's just everything surrounding the training script where we, create a workspace. We connect a workspace. We create a compute cluster. These are the twists that you have to perform. But these are like, these don't these are not things that you have to apply to your training script. These are things that you have to apply around your training script, if that makes sense. Like you have to coordinate like how the training script is submitted, how you log everything, and how you um, uh, how you manage your experiments and your data and all. Yeah.
Got it. Apart from that, we have a few more questions. Let me just take that up. Okay, we have one question. When you register the model, what is that for?
That's a good question. So register. So when I registered anything, right? When I registered, like let's say an environment, or when I registered a data set, or when I registered, let's say an experiment, it's all just for tracking it later on. So let's say when I registered this model here, I can now track it in my models tab over here. So you can see that I've actually been like I've like been testing this out a few times. So I have like 5 versions of my model. And I can also track it based on the experiment, the run ID, and all of the different properties as well. So yeah, it's just for tracking it later on. Because remember, when you're actually like working on something like this in the industry, you won't be just running one experiment, right? You'll be running like 100 experiments, thousands of experiments, and you want to be able to track your results across all of those experiments, save all of the models related to the experiments. You don't want like 1,000 screenshots in some folder on your desktop that says, like experiment 1, hyperparameter, like regularization 0.4, and then a screenshot that has um, the accuracy of the model or something, right? So this is just a much better way of tracking experiments.
Yeah, very true. We
Yeah.
also have another question. Is this thought or like this process or whatever we did today, is this thought on a job? Are we expected to learn this before joining a job?
Hmm. That's a good question. So um, it depends on the role, like in some companies, this is not going to be the job of a machine learning engineer or a data scientist. You'll have infrastructure people or DevOps people who will be doing these things for you. Um, in other companies like in mine where you're expected to hand like own your project or your experiments from start to finish, like deployment, yes, this is something that you will have to do. And you will have to maybe know a bit as well. So one of the good things about Azure is that it's like I said, like you get a lot of free credits, and a lot of the stuff, like in machine learning studio, is free as well. And the documentation is also actually really good. And like I don't say that about like a lot of frameworks, or a lot of these tools, like I don't know, Azure, like AWS's documentation I feel is like not that good. But Azure's documentation is actually, and especially Azure ML's documentation is really good, and you can learn this on your own as well. um, yeah. So Archana, I think we're running a bit short on time, so, and I have a few more things that I want to cover, so maybe we can take up the next few questions
Sure,
later on.
absolutely. Yeah.
Awesome. Yeah. So I think we've already seen this where we monitor our job. We get the model from our compute cluster, and then we can get the model metrics as well as save register a model so that we can track it. Um, but what about deploying? So to deploy a model, the steps are we have to first create a deployment script. So the script this should be like a very simple script, and all it does is loads the model, and then it should be able to take any data that you send to the script and then run inference on your model and then return the output. So that's it. We just need to create a deployment script like this. We also need like a deployment environment, which will probably be almost the same as your training environment anyways. And then create a deployment cluster, and then try to test out your model. Um, so let's take a look at how this is done. So I'm going to use another sample notebook for this as well. Um, so this is that notebook. So remember, all the previous steps that we did, they also like we use that here as well. So for instance, this step might not be important because we've already registered our model before, but in case of this like sample notebook, they've done it again. So yeah, you can register your model. If not, it's fine. Um, and then we create our environment over here, and then we register our environment. Yeah, once that is done, we need to create our script. So the script should contain two functions. One is like the init function, and the other one is like the run function. So the init function is what is used to load the model. So in case of scikit-learn, it's really simple. Just load it like this. Um, and then in again, like to run prediction, it's also very simple. So you get the raw data over here as a function argument. You can load it, and then run predict, and then just return the prediction. So yeah, so it's a very simple deployment script. um, oh yeah, so this is where we specify the kind of compute cluster, the inference, where we want to run our inference. So in my case, I've just chosen like a simple one with like one CPU core, 1 GB of memory, and you can also specify like some tags like what the data was, or like the model. You can specify other tags as well and give it a description just to help you track it better. um, so yeah, once you've specified all of these things, um, get your workspace. Remember, you always have to connect to your workspace, right? Get the environment, um, and then the inference config. and then the name of the service that you want to deploy, and yeah, just deploy it with the workspace, the service name, the model, the config that we created, and the deployment config that we created. And yeah, that's it. It's actually really simple. Like usually when you want to deploy a model, like it takes a lot of it takes time, but it's also very painful. You need to set up your environments, you need to set up like a bunch of stuff, spin up clusters and all. And over here it's just like let's see, like 23 plus some, like another 20 lines, like 6 lines. It's less than 100 lines of code. It's really really simple. um, yeah, so once we've started our deployment, we can wait and see the logs. um, so yeah, in this case it took about 3 minutes to run deployment, and then this is the URL. I think this endpoint is actually still running. So, if you're interested, you should be able to, I'll just paste this in the chat, and you should be able to query this endpoint with data, uh, uh, like submit a job, like just test if it's working or not. Let me try to copy this. Yeah. So yeah. Okay, so over here, this is like where they're downloading the data set again, and loading it so that they can query the endpoint. So there's two ways that we can query the endpoint. Remember when we run our endpoint, we get, like when we create our endpoint, we get this service object. The
Sorry
service
to
of
interrupt you, Soham. I don't think it's running because I tried clicking on the link.
you have to, you can do that. Like you have to like use curl and then send a request. Um,
Okay, got it.
Let me see. Uh, yeah, it is running. Um, yeah, it's running, but and I'll show you how you can query it.
Okay.
And you can query it after I show you. So yeah, so you get this service object, which has your, like what you've deployed. Mm, and yeah, so after you like load your test data, you can actually like use service.run and send your data. And it'll like this is just like a very quick way to test whether your service is up and running and functioning properly, and examine like the confusion matrix, to see if your accuracy is okay or not, if everything is working fine or not. So this is what this is for. But if you're someone like if you're deploying it, you can't actually give them like an object and tell them to use that, right? What instead you can give them is the URI that I sent you, and you can tell them to use um, requests, and you can post a request with your data and some headers, and then get the prediction. So yeah, you can use requests, you can use curl, if on your um, terminal or something, and yeah, and get the prediction. So the label is 2, and this is the prediction. Um, Once you're done with this, you don't want to keep the URI running. You don't want to keep like what you've deployed running, because it'll take up resources. So it's always a good practice to like just do service.delete, and this will close the resource. Okay. Yeah, so let's actually see whether so you can see if the service is running or not in endpoints. So go here, click this, and and um, yeah, so this is the endpoint. This is the link I sent you, I guess. Um, and yeah, see the logs. So you can see that, like let's see, is my request here. Yeah, so someone, like sent a request, and I guess Archana, maybe this was you trying to like click the link, and it didn't get what it wanted. But yeah, you can see the logs and all later on as well. Awesome. So yeah, this is how you can deploy your model. It's that simple. Um, so before we take questions, I have like two more things that I wanted to show you. One is, so far we've been using MNIST data, which is like an internal data, right? I also want to show you how you can load your own data and use it. So you can register like how we registered our MNIST data. We can also register like an external data as well. And then I'll show you how you can do hyperparameter tuning. So to do hyperparameter tuning, you have to define like a search space and how you want to sample from that search space. Um, so in case you don't know what hyperparameter tuning is, so remember like in the previous experiment where we were using like regularization as 0.5, we could have set that to like 0.4 or like 0.6 as well. But and that would have given us like a different accuracy. So it's not always possible for us to know what the correct hyperparameter is. Like it's not possible for us to know what the correct hyperparameter is. So we have to like run a lot of experiments. And we can do that automatically using hyperparameter tuning. So yeah, so we define the search space, we define how we want to sample from that search space. We can create a training script and then submit the job just like before, monitor the job, and then across all of the different hyperparameter jobs, we can select the best model with the best hyperparameters. So before that, let's look at how we can actually register a new data set. So click new and then click data set. So for this, I'll be using this data set like called wine quality that has like some wine like attributes and then how good the quality is. It's available on Kaggle by user RajYellow46. Um, so once you've created your data set, you can click create. You can get it from a lot of places, but I've already downloaded the data set. So I'll say local files. I'll give it a name like WWC. So the data set type. So right now Azure supports two types of data sets. One is like a tabular, which is like CSV, and the other is like file type. So like files of images, like MNIST or ImageNet or something like that. So in my case, it's like a tabular CSV data set. You can give it some description if you want. I'll just skip it for now. And yeah, browse. Uh, let's see. Open that and yeah. Um, Next. So what it's doing right now is it's parsing the data and it'll show you like it'll try to identify what each column is. So for instance, it identified that the first column is an ID. You can see that the headers are already present, but it wasn't able to identify that. So we can just go to column headers and then click use headers from file, and it'll automatically use the first line as headers. Yeah. So it identified like, the type is like a string. I don't know if you can see, but it has like this small logo that says ABC that shows that it's a string. So over here, it shows that this is like a number and all. And yeah, it identified like comma as the delimiter and so on. In case it identified something differently, or in case you don't want to load like say one column or something, you can do that over here. So for instance, I can just do this and it won't load the type column anymore. But I want it in my case. And yeah, in case like it found like it didn't infer the type correctly, you can change the type as well to some of these other types. But in my case, like it inferred everything correctly. So I should probably say like my target variable is the quality, which is a value from between 0 to 10, where 10 I think is the highest quality and 0 is the least quality. Okay, so next, and yeah, we can just confirm the details and create, and it should be able to, yeah, it's over here already. So I won't be using this. I'll be using something like I've created before because that's how I wrote my code. But it's the same data set. So yeah, let's go to hyperparameter tuning. So, like it's like how we did it previously, import all your stuff, connect to a workspace. Sorry, like error over, like typo over here. Um, Connect to a workspace, create an experiment as well, get the data set. So right now we're not using like an open data set from Azure. We have to use dataset.get by name. And like the workspace and the name of the data set, which is mine, which I showed over here, this data set. So this will load the data set, right? And then we can like register it, so that we can track it. Um, yeah, this is also like the same boilerplate code to create like a CPU cluster for training. So again, I'm using the standard D2V2 VM. Yeah, so this is where I'm specifying the type of hyperparameters. So I'm using like I'll show you the training script in some time, but I'm using a support vector machine classifier. So I'm choosing the kernel as a choice between linear RBF and sigmoid, and the penalty as either 0.5, 1, or 1.5. Um, yeah. So once I have my parameter like the samples, so sorry, like my uh, search space, which is this, and also like the how sampling, like how I want to sample, which is which is like random sampling. So I just want to randomly sample from these uh, from the search space, and I also have like a stopping policy, which is like like, so let's say like there's like 3 into 3 9 different types of experiments that I can run, right? But I may not want to run 9 experiments. I may just want to like quit the experiment early. So in that case, you can specify like an early termination policy as well that will stop the experiment a bit earlier. Um, Once we have that, we can create an estimator um, that has the source directory for the script, the entry script, packages I need, my compute target, as well as the parameters. So any parameter apart from this basically. So I just have one parameter apart from this, which is my data. Um, so yeah, once I have specified all of these things, I can create my hyperdrive run config and give it my estimator, the metric that I want to track, which is accuracy, which I will have to log again in my script. The parameters I want to sample, my metrics, and the total runs, and all of that. So yeah, once I have my config, I can then submit it and run it. Um, so I already ran it like I think oh yeah, I ran it like an hour ago and it's still running. I could have probably used like a larger machine and got it to run faster, but it's okay. Um, okay, let's see. Let me while it's running, let me show you the training script. So my script is like very simple, and I'll show you like AutoML later on. So I wrote this script like as like a bad data scientist, right? So I'm parsing my arguments first, which is my data, my kernel, and my penalty, right? And then I'm logging my kernel type and penalty as well. And yeah, so my input data set is like the wine data set. Um, so yeah, how bad of a like data scientist am I? I don't know how to deal with like the type of like string column. So I'm just gonna drop it. I'm also not going to do anything with regards to like the quality. Like I'm not going to normalize it or like convert it to anything. So um, so yeah, I'm just going to use like just the quality as is, without doing any other pre-processing or anything. And yeah, so create a normal SVC with my kernel, my penalty, and then fit it on my training and testing data set. Um, and yeah, that's basically pretty much it. So this is where I'm logging my accuracy. And then this is where I am dumping my model. So this part is kind of similar to the previous MS part that we saw. Um, so let's assume that this run, completed. What you could do after it had completed is you could get the best run by the primary metric, which in our case is accuracy, and then get print the ID of that, get all the files, and then you could register the model of that best run. Um, so yeah, I'm sorry I can't show you that because it's still running. But what I can show you is an experiment that ran like last night. So I can go to experiments. So yeah, you can see this is my experiment HP tune. Um, so this is a run that I ran like last night. That's completed running. And this is the run that is happening actually right now. You can see it's running and it's been running for nearly 1 hour. So yeah, click here and then go to child runs, and yeah. So once it loads, yeah, so it's loaded. So you can see like these are all the different experiments that were run. There should be 9 of them, or maybe more. I'm not sure. You can also see like the different hyperparameters that I used. So the kernel, the penalty, and the accuracy as well. Azure also like really they plot some of these stuff which is really helpful. So it plotted the different accuracy with the run number, and it also shows this graph which shows you like like let's say the purple line is actually our best model. So it's using an RBF kernel with a penalty of 1.5, and the accuracy is 57. So yeah, that's how you can use. That's how you can do hyperparameter tuning. Um, okay, final one last thing. I know I'm a bit like past my time. Um, so like hyperparameter tuning, it was a bit painful, right? You have to write your own script, you have to load the data, and yeah, and then you have to wait like more than an hour for it to complete running. Um, So how can you, so what's AutoML? So AutoML does all of these things automatically. And it's really simple. Just specify the data path, specify like the task and the models that you want to, like that you want the AutoML, task to iterate through, and then let AutoML do everything basically. And it'll just return your best model, and then you can also deploy it as well. So let's see how that works. So I have my AutoML uh, IPython notebook over here. Same as before, connect to a workspace, choose an experiment name, experiment. Um, oh, I think this stopped running, but that's fine. I can show you like a run, like a previous run. Um, get the data set by name. Um, and then like so here like I just showed like an example as to how you can register like another data. So for instance, here is where like I get the wine data, and then I split it into training and testing randomly, right? So since it's random, you should ideally like save like that version of data. um, so yeah, so I can register that like this with like a different name and all, um, and the test data as well. Start my CPU cluster for submitting my training job, and then yeah, so specify the settings that I want for AutoML. So yeah, so I don't want it to run for a lot of time, so I just specified like a timeout. So after this time, just stop running. Um, then how many? Then the timeout for iteration, maximum concurrent iteration. So if I want to run multiple stuff at the same time, because remember my nodes can scale up, so I can do that as well. Um, and yeah, the metric, which is accuracy. Um, yeah, so that's it. That's my AutoML settings. And then my AutoML config, which will take in my AutoML settings in addition to the data, so my training data and my validation data, the column that I want to predict, which is quality, I can choose like some models that I don't want to run. So like for instance, linear SVM is, I don't like linear SVM. No, I'm just kidding. But yeah, just don't run this. Um, in case my experiment reaches like an insane score of 99.84, then I wanted to just stop anyways. Um, I don't want it to improve any further. And yeah, the task which is classification and log to AutoML errors.log. Submit my run. This is how you can uh, um, uh, view it, like see your run, and then um, once it's finished running, you can get like the best model, right? The best fitted model. And yeah, so the cool thing about AutoML is that you already get like when you run it. So remember, like I haven't specified any scripts here, right? So AutoML actually builds all the scripts on its own. So it also sends me like a scoring script. So I don't even need to write a script that will deploy my model. I get it automatically. Um, so I can download those files. I can download like the scoring file and the yeah, and the inference file, and then I can actually deploy it. So yeah, so you can see I've just specified like that same script over here to deploy with like one CPU and 1 GB of memory, and yeah, and I can deploy it. So basically, I didn't have to do anything. I just like had to specify my config, and then AutoML does everything for me. It even gives me a script that I can automatically like deploy, and deploy it. So let's see like a previous run. Hmm, I think it's this one. Yeah, it's this one. So these are all the models that AutoML trained, and there's a lot of them. These are also the accuracy, right? And yeah, so you can see that the voting ensemble model got the best accuracy. Another cool thing about Azure ML is that it also has this thing called view explanation, which kind of explains um, like how your model, like why your model made a certain decision. And yeah, oh yeah. So what's this? Let's see. Mm, Yeah, I'm really sorry. I'm not sure what. Oh yeah, this is what I wanted to go. Yeah, so the importance of individual features, and you can see like just how important each feature is for to predict something. Like that explains a certain prediction. Um, so let's see. Yeah. So in this case, for this prediction, um, like our volatile acidity and alcohol mean like sulfur dioxide and stuff like that. This is how important it was to come to the conclusion that the quality of the wine is this. Yeah, so that's pretty much it, and I can like show you like the models that has been registered over here as well, and then points. So yeah, that's it about AutoML. And like just some other Azure ML features. So Azure ML also has like data labeling and versioning, which is I think really cool. So in case you have unlabeled data, you can do that as well. You can also deploy to like edge devices like microcontrollers and stuff. You don't even have to honestly write code for AutoML. There's like a UI that and there's like also like a drag and drop training as well. So that's really cool. You can also create pipelines. So like pre-processing pipelines, you can create and you can store them. You can also have like you can encrypt your model. So for your model security, model implement interpretation, which is something that I showed right now. And yeah, finally, like Azure ML, it has like really awesome documentation, and I really and I think it's something like it's one of those few things that you can actually honestly learn on your own, just by reading the documentation, and also by looking at all of the sample, um, like the example notebooks and examples. Yeah, that's it. Um, and if you have any questions, I'd be more than
So
happy
we
to
have
take
one
them.
more question. Question: Are there any specific situations that AutoML are best used for?
Mm-hmm. Yeah. So I think right now it's best used for like very simple data sets where you don't have to do much pre-processing or cleaning. Like for instance, like the wine data set I just showed you, or like let's say like MNIST or like some image data sets. Um, if you have a data set where there's a lot of pre-processing steps that's needed, it's really not good for that yet, but people are working on ways to improve it.
Got it. Okay, thanks. I think that is it. I know we are a little over our time. So thank you so much everyone for joining in. I hope you guys have a wonderful day or a wonderful evening or a wonderful night wherever you guys are joining us from. Do join us for some of our other events on Women Who Code Cloud too. Thank you so much everyone, and thank you so much for Soham for presenting today's
Yeah,
content. We really enjoyed it. Thank you
thank
so
you.
much. Bye bye everyone.